In this episode, we talk about building and scaling APIs. Hi, and welcome to ScalarCode.com. My name is Christoph Limpler, and today I'm joined by Travis McChesney, who is the Director of Engineering at a company called Cloud Elements. Cloud Elements is a platform for API integration and management, and so we're going to learn how they built this platform, including their architecture setup and their development pipeline and culture, which is incredibly important. And also, we're going to learn about how they've implemented certain features like performance analytics and cool things like that, so that we can turn around and take what we've learned from this episode and build amazing things. Speaking of building amazing things, if you'd like to try building your own APIs from what you'll learn in this episode, grab yourself a DigitalOcean droplet for free for a month by going to scalarcode.com/DigitalOcean. And then you can implement your own tracking or error tracking for any application by going to scalarcode.com/rollbar, ROLLBAR, which is just an amazing service. In fact, these two companies are fast growing companies, and so is Cloud Elements. And so let's see how they do it. Travis, welcome to Scholar Code. Thanks so much for being here.
Thanks, Chris. Appreciate it. Glad to be here.
So before we even start about all the technical details concerning Cloud Elements, I want to learn a little bit more about you, like where you come from, a little bit about your background, and also what you do at Cloud Elements.
Yeah, so for me, I'm a computer science graduate, so that's where I started in the whole computer game. Been working on computers kind of all my life. And then, after college, I got a job at a healthcare payer company, a large healthcare payer company, healthcare IT, sorry, company. And I kind of worked with a lot of Perl and C#, different things there, and then moved on to Cloud Elements. So really, this is my second gig. It's been probably 10 years since college, but it's really my second gig. And I'm loving being here at Cloud Elements, kind of the startup culture and doing a little bit of everything. So it's been fun.
So you say you've been working with computers pretty much your whole life. By that, do you mean building the hardware itself or like putting together pieces and building those computers as well as software, or is it primarily programming and building software like that?
Kind of both, actually. I mean, when I was in, I think, elementary school, that they had the Apple IIe was kind of where it started, and actually, my best friend just sent me a picture from an Apple IIe. He had loaded a program that said 1994 on it, and it was like, hey Trav, it was like a graphics program from 1994. I'm like, wow, that's trip down memory lane. But yeah, started with programming, and then kind of built a few computers, but definitely most on the software side.
Yeah, it's funny. I actually started more on the hardware side of just piecing things together, and I remember setting up a liquid cooling system, and it was just fascinating to me. I'm like, oh, this is the best thing ever. I want to go into computer engineering and deal with that aspect of it. And then after about a semester or two, I realized that really my heart was not in it, and I much preferred the software aspect of it, where you can quickly iterate on different versions of software, and you can push something live, and you have thousands or even more people using it. And I thought that was the coolest thing ever. So I'm always interested in hearing different backgrounds and what your interests are and how you ended up being here. So that's always fun.
Yeah, I think we're similar in that way. I actually started at CSU with a ECE um, degree, but yeah, after a couple semesters, I went over to the CS department. So, and
All that
got,
math.
yeah, exactly. Totally different math too. So
Yeah.
it was a whole change.
Awesome. So what do you actually do at Cloud Elements today?
Yeah, so I mean, my title is Director of Engineering, but what that kind of means is I try to come up with some of the best practices for coding and some of our development processes and things like that. And as much as I can, I try to continue coding. That's what I love to do, and as much as I can, I try to do that, and it keeps me kind of, on pace with what's going on in our development team, as well as like figuring out what best will work for our team from the development standpoint. So a little bit of everything. I mean, I was employee number one technically, so there was a lot of pretty much everything going on at the time, and so having a hand in all that was really cool. And now it's kind of leading the engineers, being a mentor, and making sure our processes are set up the way they need to be.
I definitely want to talk more about those processes because they are so incredibly important. It's not just about building code and deploying that. There's more to it, and it's sometimes very hard for organizations to grow into that, especially if they're a smaller organization, they have fewer people on the team, they don't have the resources to really spend on building processes and things like that. So they just kind of, stay at doing the same thing they've been doing over and over again. So hopefully we can dive deeper into that and learn a little bit more about that. We are going to be focusing a little bit more on APIs though and building those, since I know a lot of people listening are probably working on APIs or will be in the future. So I do want to cover that. Now, before we even dive into that, can you tell us a little bit more about some of the features that Cloud Elements has and how you've built those features?
Yeah, for sure. So, as far as what Cloud Elements is, we're basically an API integration platform. So, you can publish, integrate, aggregate, manage pretty much all your APIs through just this one platform. And what that means, you know, basically is, there are kind of two main things that you can do with it, which is connect to categories of cloud services. So you take something like CRM, you've got Salesforce.com and others in the space. If you want to integrate to those APIs, normally you have to figure out, well, how do I integrate to Salesforce? What's their authentication like? How's, this, that, and the other thing work with their API? Well, if you integrate with Cloud Elements instead, we've already integrated and figured out how to integrate with Salesforce.com and several others. You can just come to us and the API will look the same, which is a pretty cool thing. So you don't have to, dig through documentation for 20 different, endpoints to figure out how they work. You just figure out how Cloud Elements' API works, and we've tried to make it as simple as possible. And then you can connect to those others really easily. And then the other kind of major use case for our platform is using it to synchronize data between cloud services. So if you've got, some contacts or something in Salesforce and you've got support tickets in Zendesk and you need data to flow between the two, we have a pretty cool toolkit that you can integrate those two together and, let data pass to and from by transforming data as well, getting those over to where you need them to be. So those are kind of the main points of what our platform is aiming to do. And then I don't know how much you want to get into, how we've done that, or where you want me to start on the how.
Well, we'll decompose it and take it one step at a time because there's a lot there. But let's take a look at an example use case that I use quite often, where I'm always using Amazon S3, which is a file storage service, and then something like Dropbox, right? So when I upload something to Dropbox, are you able to send a request to your API and also send that to S3, or vice versa? Is that kind of how it works? I'm trying to wrap my head around the whole process.
Yeah, absolutely. And it's pretty flexible. So we do as much as we can with webhooks. So if you upload something to Dropbox, let's say, Dropbox has a pretty good webhook functionality. So they'll, send us a webhook. You would basically set it up to tell Cloud Elements that, hey, we received a file. So we would get that. And you could do any number of things with that webhook. You can fire off what we call formulas, which is kind of like, workflow, I think, is the normal kind of industry term for something like this, where you could say, okay, well, here's the name of the file. Can you go grab that out of Dropbox and then dump it into S3? And we could do that for sure. So that's definitely a use case that, our platform would handle.
Awesome. So let's talk about the infrastructure a little bit more. What powers all of this integration? For example, when you send a request, where does that request go? How does it get processed? And what pieces of infrastructure does it touch?
Yeah, so we leverage AWS pretty heavily. So we have most of our infrastructure hosted there. In fact, I would say all of it is hosted at AWS. From the top part, we use, like an Elastic Load Balancer in AWS, and that kind of balances over to some internal Nginx web servers that we have. And then those trickle down to our app servers, which are Java-based, so they run Tomcat. And that serves a whole bunch of other stuff underneath the covers as well. So, I can get into all that too. But that's kind of like, where the first touches are. It goes Elastic Load Balancer down to the, Nginx, and then down into Tomcat. And then we've got lots of stuff under the covers making all those things work.
What about the database? Do you use Amazon RDS, or did you roll out your own on EC2 instances?
Yeah, so we did not start on AWS, or we didn't have all of our infrastructure in AWS initially. So we use Postgres for our database, and that's kind of been there since the beginning. We also leverage Elasticsearch as a data store. So for those things that don't really match the data model of, you know, Postgres or what it can handle, more time series data we kind of throw into Elasticsearch. And yeah, I mean, we host them on AWS, but we don't leverage too many of the AWS specific kind of services just yet.
Is there a specific reason for that, or is it just because you didn't start there and you haven't transitioned there yet?
Probably that, yeah. I mean, we transitioned to AWS for all of our environments relatively recently, so we just haven't kind of put a ton of research into those, those other services that AWS offers, and kind of going that way. We're definitely not opposed to it. There's a lot of benefits that we can see going that route, but it's just not happened yet.
Sure, and then sometimes you don't really have any major difference, so why would you actually spend the time and risk downtime and things like that when you're not going to see a drastic difference? But I am always curious to hear if people are running production loads on AWS, which services they're using and which they're not, and why. Oftentimes it's just, we started using this and we haven't really migrated to it yet, but that's always an interesting question. What do you run to manage all of those things? Are you running something like Chef or Puppet or Ansible, or how do you manage the infrastructure?
Yeah, so kind of building out our infrastructure, um, we tried to use Ansible for a while. It kind of got unwieldy for the amount that we wanted to do with it. And so we kind of took a step back and then started on with just basic shell scripts, actually, to get some of our infrastructure going. Um, and going forward, we're using a lot more in the microservice realm. So we've got, we're making use of VPCs within AWS so that we can kind of segregate some of our microservices and things like that. For those new microservices, we're actually using Terraform from HashiCorp as our kind of deployment infrastructure deployment program, and that's been working out pretty well for us as far as getting things up and running pretty quickly, and eventually allowing us to scale really easily as well.
Speaking of scaling, how do you handle spikes in traffic? I assume sometimes you get more API requests than other times and things like that. Do you have auto scaling running, or how does that work?
We actually don't have auto scaling at the moment, so when we get spikes, we actually have a pretty good amount of spare capacity, I would say. So, we have a certain amount of web servers going, or app servers, I should say, that can handle the spikes as they are. We're definitely growing though, so we're on that path to getting more of that elastic and automatic scaling going on. But currently, it's we would kind of, if we needed it, we would use some of those um, shell scripts or Terraform scripts to get those up as quickly as we could currently.
Would you say you have any major pain points as far as scaling goes that you guys haven't nearly addressed yet, or for the most part, is it pretty smoothed out?
Yeah, I mean, and like I said, we kind of, well, I don't know if I did say this, but we started as a monolithic application. So there are kind of a lot of pain points, right? And we've kind of over the course of a couple years tried to pull some of those things out, figure out what those are, and fix them. So um, what we've started to do, rather than kind of we've had grand plans of, oh, let's just rewrite the whole thing and something different and make it microservice and whatever, but that's not a very good idea in my opinion. So what we decided to do was kind of pull things out that we think we could pull out into microservices. So some of like the formulas that I mentioned, running some of the JavaScript that's custom to those, pulling that out of the main program, pulling events out so they don't hit the single application, so it's not a single point of failure, and kind of just breaking things out that make sense. And then, so that's been a big one. And then another one, as far as pain points goes, is putting the wrong kind of data in Postgres. So we started doing that, and we started putting, a bunch of time series stuff in there. And so we were always, running ourselves out of disk, or, just overloading the database. when it shouldn't have been. And so we've been migrating those kinds of things out to Elasticsearch and at least scalable database systems that can handle that sort of thing and are designed for it. So that's kind of all been resolved, and it's running pretty smoothly right now. But we've got more work to do pulling additional things out. But definitely those are some of the pain points that we've had with having a monolithic application and a sort of non-scalable or tough to scale database in Postgres.
Right. What are some of the main differences between something like Postgres and Elasticsearch?
Yeah, so Elasticsearch and Postgres are pretty different in that Postgres is your more relational database model, and Elasticsearch is kind of less. It's schemaless, right? So you can just sort of put data at it, and then you can kind of slice and dice the data however you want, but it's not necessarily in a structured query language like you would in Postgres. And with Postgres specifically, and obviously we're not really, I would say, experts in any one of these. So I mean, there are probably things that we could do better that we just haven't come across yet. But in Postgres, it's tough to scale. So you've got you can scale vertically. You can add RAM and disk and things like that. But it's really tough to get Postgres to scale horizontally, meaning kind of sharding or moving information from node to node, where you don't have to worry about, well, I've got a terabyte disk already. How much bigger can I get? You can just add more nodes in an Elasticsearch situation, and you get redundancy with Elasticsearch, and you also get the scalability with it. And time series data and event driven data is really big. I mean, there's lots of it. There's tons of it, and so throwing that all into a relational database didn't really make sense for us, even though we were doing it for a while when we had low volume. Putting into Elasticsearch was a lot better. And the reason we chose Elasticsearch versus, like a Mongo or some other kind of system was we were using Elasticsearch already for some of our logging and monitoring, things like that. And we knew how to use it. We already had it set up. We had the servers there, and we decided it would be the best option just to keep with that, stick with what we know. It wasn't really worth it, kind of as you were mentioning before. Is it really worth it to move to a different technology if the benefits aren't necessarily that great? So, we stuck with Elasticsearch, and it's been working pretty well for us. We've, put in some custom dashboards using Kibana on our elk stack. We use Logstash as well. But that's kind of the difference there between our Postgres and Elasticsearch trials.
You actually just answered my question I had in mind of why Elasticsearch versus something like Solr, or I think there were a few other similar things that I'm not familiar enough to know whether there are big differences between them, or if there are better use cases for Solr versus Elasticsearch. If anybody wants to look it up, it's Apache Solr, and I'm not sure if you know of any other ones that people could look up or not, but I think there are a few in that space, but not that many of them that I know of at least.
We had looked at Cassandra as well, I think, which is a nice scalable database. There's also MariaDB, which I think is a nice scalable relational database, I believe. Don't quote me on that, but so anyway, it was a matter of kind of, well, we've already got this. It's working well for us. We know kind of how to administer it and things like that. So let's just keep going. If there's, if there are any other pain points, we can change, but it's been working out well for us.
I mentioned a discount from DigitalOcean at the beginning of this episode, and I'd like to share why I thought this sponsorship could really benefit you. DigitalOcean is not only one of the easiest cloud platforms to get started with, but it's affordable and it's built for scale. Don't just take my word for it. Look at the platforms using DigitalOcean. You've got Docker, Red Hat, Akamai, Zendesk, and a ton of others. In fact, it's the fastest growing cloud infrastructure provider. DigitalOcean lets you customize your own infrastructure or choose from pre-configured one-click images like Node.js, Docker, and a bunch of others to quickly get you started on your project. Go to scaleyourcode.com/DigitalOcean and type in promo code ScaleYourCode, which is all one word, and you will get 1 month free on a 1 gigabyte droplet. An entire month. Do you know how much you can learn or even build with that much time? Go to scaleyourcode.com/DigitalOcean and type in promo code ScaleYourCode. And then come tell me what you built. I'd love to see it. Speaking of Elasticsearch and searching and things like that, I know that you give some insights to customers regarding performance of the API and things like that. Do you also run any internal analytics that you can search through Elasticsearch or something like that? Or
Yeah, absolutely. So we have been working on some internal dashboards and actually improving our metrics and monitoring over to Elasticsearch that we can then pull back. I was just seeing if we can, if I can pull up a couple of those. So um, we have some dashboards that show us API traffic, response time, and then traffic by account and by element. And an element in our system is basically kind of like an endpoint, salesforce.com or Dropbox or something like that. So we can see what's happening and we can slice and dice the data pretty well so we can figure out who's using traffic and what endpoints are really getting hit the hardest, and things like that. So yeah, we definitely leverage Elasticsearch for a lot of those things.
oh, so that's the kind of data that you're talking about where it doesn't really make sense to store it in Postgres. Instead, it's better to store that kind of information in something like Elasticsearch.
Exactly. So yeah, metrics is one of them. And then another one that we use kind of in the application itself is like event data. So when I mentioned, getting an event from Dropbox, we would store that event in Elasticsearch versus something like Postgres because we get, you know, thousands and thousands of events continuously. And so we're putting those in Elasticsearch because it can handle it and it can scale that way. But um, Postgres it kind of falls over in that scenario. So kind of that time series event related data we put in there as well. Yeah.
Just out of curiosity, you mentioned event driven. Do you guys make use of AWS Lambda at all for anything?
We don't actually. We looked into it a little bit, and I think some of the limits that are currently on there were not quite up to what we would need because we've got some payloads that are pretty big. Some of the event payloads we get are quite large, and I think would blow out what Lambda would allow. But we're definitely keeping an eye on that one, and there's some potential there for some of the things that we're doing. We just haven't leveraged it yet.
I'm curious to see what direction they go with Lambda. There's so many things they could do with it, and obviously it's AWS, so they're always rolling out different features and changes. So that is going to be interesting to keep an eye on it and see how that goes. Now, as far as security and protecting against things like DDoS attacks or noisy neighbors where you have one customer who sends a lot of requests to an MPI endpoint and that might affect other customers. How are you able to implement a layer of security before that even reaches your infrastructure? Do you guys have something in place for that, or how does that work?
So that's something we're actually in the middle of implementing. So we've got so I think there are a couple different things there, and probably the two things are rate limiting and then the noisy neighbor problem. So as far as rate limiting, we haven't really had the need to do that yet. And like I said, we're kind of in the middle of analyzing the data that we have from Elasticsearch, all of our metrics, figuring out what would be kind of the right way to um, to limit calls and how we want to do that. Do you do like AWS does and charge, like per use, or is there a tiering system, or that kind of thing? We're kind of figuring that out now. And like I said, it hasn't been a huge problem. We can kind of pinpoint things as they happen now because we're not mega scale yet. And then the noisy neighbor issue, we've actually leveraged Kafka a lot in our infrastructure. So when we get an event or something, we dump it into Kafka versus let's try to handle it right away, which would kind of mean that you could get flooded with events. Well, we have metrics around Kafka. So if we dump all of our events to Kafka and then pull them off at when we can see, is there a queue that's growing rapidly or something like that? And we can kind of figure out what's going on pretty quickly with our monitoring and alerting. And then if there are any issues there, we can kind of shut that off. And the noisy neighbor thing, we're able to use Kafka's partitioning, which we partition by account. So, or I guess a subset of accounts. So, if you have one noisy neighbor, they're not going to take out everybody. They might take out one or two, other accounts that are in there, but at least that gives us enough time to figure out what's going on in the Kafka queue, who's, kind of causing the issue, and then what we need to do about it. So I would say Kafka's been our big our big helper there as far as our message broker. We can kind of dump things out there versus just kind of taking things as they come and potentially falling down under huge load. We can defer that to Kafka and then pull it off when we can.
So in Kafka, sorry, you said you have a subset of accounts that are kind of walled off from the rest, right? Is that a software imposed restriction or is it hardware imposed, or how does Kafka work in that domain?
Yep, that's software. So basically, we have an n number of app servers, right, and they connect to Kafka with n number of partitions. So those partitions get assigned to a particular app server. You could actually have a partition go to 2 or 3 app servers, let's say, and those app servers will, and only those app servers will be working off of that partition. Then you've got the other, app servers that aren't dealing with that particular partition. So, so in that way, it's possible that to kind of segregate large amounts of traffic in a particular area from other parts of the application.
Gotcha. That makes a lot of sense. There's another company I interviewed that has a lot or deals with a lot of data coming from customers where they can then display that data on charts and things like that. And actually, that's very similar to what you're talking about as far as trying to reduce the noisy neighbor. I think they implemented a very, very similar solution. So it sounds like Kafka is a really good option for that kind of use case for sure.
Yeah, Kafka's been pretty great. It's a little bit, it was a little tough to integrate with initially. Again, we're Java, so trying to figure out what to do with partitions, what do we do when we're shutting down, and committing and things like that. So there were some definite challenges with that, but it's now that we have it, kind of where we want it, it's definitely been a good one for us.
And that interview I just mentioned, by the way, is with Keen.io. So if you're interested in hearing more about what we're talking about here, definitely check out that episode, Keen.io, Keen.io. So that's a really cool interview too. Great. So are you actually able to cache any of these calls, or is it every time it's a different information, or you're not able to actually cache it? How's that work?
Yeah, so we use Redis as a caching layer, and actually we use Redis for lots of different things. We use it for um, the initial step in our Logstash system. So basically, all of our logs go directly to Redis first, and then Logstash pulls them off and puts them in Elasticsearch. So that kind of keeps things very asynchronous. But as far as actual caching goes with Redis, what we can do is cache our element instance data. So each of our element instances basically contains authentication information, transformation of data information, and that kind of thing. So however you've set up your Salesforce.com accounts to look, and whatever your OAuth token for Salesforce.com is, we can cache that in the caching layer at Redis. And if we're getting thousands of those calls, we don't have to go to Postgres for it. We can go to a faster, Redis in-memory store for that. If we have to switch out OAuth tokens, refresh OAuth tokens, or someone goes in and changes the transformation or something like that, then yeah, we have to dump that. But for the most part, people aren't changing their instances that often, and we can just kind of keep that in cache, keep it warm in there, and then and then get some pretty good gains off of that.
When you say instances, by the way, do you actually mean AWS instances that you spin up in the backend for them?
Yeah, sorry. So an instance in our system refers to an authenticated instance into an endpoint. So if you come into Cloud Elements and you say, oh, I want to connect to Box or something, you click Add Instance, and that will take you through the OAuth flow at Box, and then it will create an element instance in our system. Basically, that's just kind of like a little um, piece of data that says, here's how you connect a box, here's your OAuth token, and things like that. So that's really just how we identify a particular connection to an endpoint.
Gotcha. I want to take you back to the monitoring that you briefly mentioned, and you mentioned some of the tools like Logstash and things like that for logs. Are there any other tools that you use apart from Elasticsearch and all of those to collect and aggregate all of that data and then store it somewhere and maybe analyze it?
Yeah, so one of our dreams, I guess you could say, is to have all of our logging and analytics and everything sort of um, in one spot, right? But That's not the reality currently. We have a bunch of different systems that we use for monitoring and alerting and metrics and things like that. We use Datadog actually quite a bit, which is really easy to use. I mean, you just put in their agent, and they have integrations to, pretty much anything, Tomcat, Redis, essentially all of our stack. You can just install one of their agents, tell it you've got, a Redis client or a Redis server or something, and then it will start shooting data over to Datadog, and you can immediately start seeing results of that. And you can really easily put monitors on that, alerts, anything that you need. So we've been leveraging that for, some of the system level kind of RAM, CPU, things like that. We also use New Relic a bit. So New Relic is really good for getting into the JVM, telling us, how's our garbage collection doing, how's our memory looking, and things like that. It does tell us some throughput and response times as well, kind of canary in the coal mine type stuff there.
So that's how you get some of those response times that you can then pass off to the user and said, hey, this is how long it took to process this, or does it also involve other times that or to reply to the or to create and finish the API call?
Yeah, so from a New Relic standpoint, that the response time isn't terribly helpful. What we provide to users on the console, in our web, on a web page in the web console, is actual API times, or I'm sorry, response times, and the number of API calls you make. And that's a little bit different. That actually is stored in Elasticsearch. When you make a call into Cloud Elements, the first thing that we do is say, hey, start the clock. And then the last thing we do is say, hey, end the clock. And then, kick that out to Elasticsearch, and that's how long your call took.
Gotcha.
Obviously, that doesn't take into account the network delay potentially between the client and us, but at least it tells you, how long we took to handle your request. So that's there, and then we have, like I said, some Kibana dashboards to show us those values as well, and we can kind of slice and dice that data there as well. So, yeah.
You offer something called data mapping with your element mapper, and from what I understand, this allows you to map and normalize data objects and fields between those cloud services that we're talking about. How does that work? How are you able to do that kind of stuff with the data?
Yeah, so basically, you can open up the data mapper, and what that allows you to do is choose an object from your endpoint. And I keep going to Salesforce because we've that was probably one of our first ones that we did, and they're really good as an endpoint. You can choose, like, say, accounts, and then what we try to do as much as we can is discover what fields you have, like on an account object at Salesforce. And we say, okay, let's say you've got first name, last name, account name, whatever it is. We try to populate that as best we can. We can discover it where possible, or we've got a couple different ways to do that. And then you can create your own object in our system called My Account. And you say, well, I want my account to have first name and last name only. Like, that's all I need. Well, then you can go into another CRM system, pull that same window up, and then match those fields. Maybe it's first underscore name. You can map first underscore name to your My Account object, and then you can do last underscore name to your My Account object, and then you can make API calls against /My account. So rather than getting the exact data from Salesforce or the exact data from the other, system B, whatever it is, you can just say, get me My Account, and no matter which system it comes from, it's going to look like first name, last name as you want it to look. And that gives you kind of a lot of flexibility, because in your own system, it helps. You can always expect the same structure of data in your system, regardless of which endpoint you're hitting. It also is nice for syncing data between systems. So you can basically just say, well, I only need to sync the first and last name anyway, so let me make an object for that, and then I can move that around to a different system. And it really kind of affords you a lot of flexibility there.
If there's one tool I recommend to help improve your application and development process, it's some kind of error tracking tool like Rollbar. Error tracking is one of those things that I sincerely wish I had started using earlier in my development career. Even if you think your application is flawless because users aren't reporting bugs, I'm willing to bet you'll be surprised at how often users run into an issue with your application when you turn error tracking on in production. The thing is, it literally takes 5 minutes to install it, and you can get started for free for 90 days with my special URL. Go to scalycode.com/rollbar and try it out. You'll be really glad you did. When it comes to the code, let's switch the focus a little bit more from the infrastructure to the code now. How do you test your API endpoint calls and things like that to see whether maybe it's your code logic that has issues or whether it's another API that isn't returning the proper response because maybe they have something going on their end? How are you able to have that kind of visibility in your code?
Yeah, so with our elements builder, that's another one of our kind of excuse me, integration toolkit um, uh, products. You can essentially create an element basically just by describing it. So as long as it's a relatively RESTful endpoint, it's got OAuth authentication or basic authentication, you can you can create an element basically just by describing what are the resources and what do I need to save off of it and things like that. To go along with that, though, you can also essentially try it out and trace what's happening. So if you say, I want to try this out, we will show you what exactly we're calling on the endpoint and then what they're returning. And does that even look right to you? And is that what's supposed to come back in general? So that's how kind of users of the system can check to see if things are working the way they should. Obviously, as developers of our platform, we use that to create new elements and things like that. When we're doing it, we have access to the code, so we can step through it and say, oh, well, the endpoint is not returning something that we think it should, and figure out how to fix that. But we've tried to give as much flexibility and power to the user to do that as well, as far as that goes. Did you want to know about kind of how we do testing overall?
Yeah, that'd be great. Let's move into that actually. Yeah.
Okay, yeah. So as far as the testing goes, we have a legacy system and a new system, so kind of a theme there. But what we started with was the robot framework, and a lot of people haven't heard of that, but it's a Python-based automated testing facility or library, I guess you could say. So we started with that, and basically what we ended up doing was writing tests for each of our endpoints and essentially all the resources. So Salesforce, we've got a test for that to say get accounts. Let's make sure we can get accounts. Does that return an array? And can we get page 2 of that and things like that? So lots of things there. What we've started to do is moved over to a JavaScript-based solution using Mocha. And so we've started to convert those tests, and we've tried to make it as easy as possible to get those tests in. So in our engineering team, we are all responsible for creating those tests and making sure, sort of proving that what we're doing is working. So we've tried to make the testing framework as easy as possible for our engineers to say, just go in and say, this endpoint should be able to do a full CRUD, which is create, retrieve, update, delete on accounts, and we take care of the rest in the framework, and then that becomes part of the test suite. And so whenever we run our test suite, that runs, we make sure it works. If something's wrong, we can take a look at it and figure out what's changed or what we need to change.
Speaking of that, can you tell us a little bit more about your development culture as a whole? Maybe how you, or the pipeline of, or the application lifecycle of when does it touch which team and how do the teams collaborate and things like that?
Yeah, absolutely. So, we've got a couple of different inputs into the product. So we've got, like sales requests, people wanting to know if we do a particular thing, and then we decide that's a great idea. We don't do it, let's do it. So, it comes in that way. We got customer feedback, from existing customers saying this works great, but I'd love it if it did X, Y, Z. And then we also have internal input, which is, engineers like, yeah, this could be better. Let's, we could definitely do this better. And so all those things are what come into our pipeline. That's what feeds our pipeline. And then we have, product management, which is really just one or two people right now. And they decide, hey, are these things worth doing? Is this something that a bunch of people are requesting and things like that? And once we've decided that, yes, this is something we really want to do, then we pull that in, create user stories for it. And actually, we're leveraging GitHub and ZenHub together for kind of our Kanban/Scrum boards. And we create user stories for that. Once those get in and someone pulls that off the top, like we've prioritized everything, someone pulls that off the top, they're responsible for, kind of setting up any design sessions or talking with other engineers, getting opinions of, how we think something should work, if it's not clear or if it's kind of a bigger story, things like that. And then we go on from there. Yeah. Did you have a?
I was gonna say, and I was just thinking about this out of the box, where how would you deal with this? Say, for example, you went to a new organization. You start there, you're a few weeks or maybe a month in, and you realize that the entire development cycle pipeline is all in disarray. Like maybe you just show up and you're like, wow, you guys haven't really worked on having a pipeline, and there's not really collaboration between different teams, like the Q&A team and development team, security team, things like that. How would you change that? How would you instill the culture where there is a pipeline, there is collaboration, and things like that? Does that make sense?
Yeah, definitely. And I think, we've struggled with that too. We had a QA team for a while, and it's a tough thing to figure out, when does something go over to QA, when does it come back, and then how do you deal with, um, you know, committing to points on a sprint or anything like that. But I think the tools are really helpful. We started with, we used Jira for a while, and we used Aha for some ideas, and it seemed like it was very fragmented. And taking some feedback from the engineers, we sort of try to streamline that into, let's just have one place to go, which is GitHub. ZenHub integrates into that. And then let's make sure that, we're all on board, product management, everybody's working off the same, playbook or whatever. They're all in the same place. And let's make sure that it's all organized in one spot, and that's all you have to do. You just go to one spot for your work. You can figure out what you need to do based on that. Um, I mean, if teams are communicating, that's a tough one. But I think that communication, tooling, making sure everybody's on the same page, I think is just going to be key to get that to work. And it, there's definitely no one solution for any particular organization. We definitely had to work through and figure out what our engineers wanted to do, what would actually work for the product folks. Can they work in GitHub as well? It's more developer focused, but is it easy enough for them to use and put ideas in and put stories in and things like that? So I think just listening to kind of, the organization and figuring out how you can unite them is probably going to be the best way forward in that.
The communication is a tough problem, and how do you solve that? I mean, I'm not sure. It probably depends, like you said, but maybe encouraging that kind of discussion and communication, and maybe it has to do with tooling as well, where it makes it easier to send a message to someone and say, hey, I've got a question about this, or hey, check this out and give me your input. Those tools, maybe the culture as well, where it's more open and you're not afraid to ask questions. Yeah, things like that. Other than that, I mean, it is a difficult challenge for sure.
Yeah, I would agree. I mean, we've been using Slack for a long time. That's kind of
Yeah.
pretty standard, I think now, and that we have such a great culture, and we want to make sure that we maintain that. We're relatively small, right? We're about 50 people, and that's kind of getting to where you need to make sure that you can keep that culture. And so we haven't really had too much of a problem with a lot of that communication. We've had to try to make sure that we don't put up silos, in between teams, because that's can be detrimental as well. Like you mentioned, you want to make sure that you're comfortable, going from team to team and saying, "Oh, I just have a question," and sometimes that can create some animosity because you've got engineers who need to do their work, but then you've got another team like coming in and bothering them, and you think, there's context switching going on. So it's definitely a balancing act, and trying to make sure there are no silos, but then also making sure there are some sort of barriers there where you're not just everybody's, it's a free for all. Anybody can kind of bother anybody anytime. And so I think some of that asynchronous communication through Slack is helpful. And as long as people, are respectful of other people's time and things like that, you can make it work pretty well.
In closing for the interview, you did mention that you guys have 50 people on the team, which, relatively speaking, that could be big or small depending on who you ask. But I think I was reading right before the interview on Google that maybe it was last year you went from 20 people to 50 people. Was it all in a year or?
Yeah, I think it was probably a little more than a year, but
A
yeah,
little bit more
in
than you.
a
That's
pretty short.
still a relatively short amount of time for adding 30 people to the team. And so you were talking about keeping that culture and things like that. Does that start with hiring and finding the right person and the right character and personality that can actually fit in your team, and then maybe reinforcing the culture that you have, or is it a balancing act of letting the culture grow beyond what it currently is and just kind of letting it take root and do its own thing? How does that work?
I think it absolutely starts with hiring, and a lot of the things we look for when we hire are, at least on the engineering side, we hire a lot for passion. We want to make sure that someone's passionate about what they do and about learning. Um, and we've been talking to some recruiters lately, and we've asked them similar questions like, how do you make sure that someone fits the culture? And it's a very soft and squishy thing. There's not one answer, but it's kind of a gut feeling, more or less, when you're talking to someone and you try to get a sense of if they would fit your culture or not. But I absolutely think that you need to try to find, or try to make sure that whoever you are hiring will fit your culture, whatever that may be. And that's not to say that you want to just keep your culture as it is and there's no room for kind of growth or difference. But because everybody's going to bring their own flavor of culture no matter what. But kind of that baseline, like you're definitely hard workers, you're responsible, you're this, that, and the other thing. You make sure someone is that and they're passionate. We feel comfortable bringing them on, and they kind of keep that culture. As far as after that goes, we have actually a culture club within the organization that tries to make sure that we continue that culture. Like we'll do outings, or we've got hike days once a month, or ski days in the summer, in the wintertime, to kind of keep that camaraderie and the team together. And so I think that was a pretty cool thing. We've got a really great team, trying to keep that together and keep us all on the same page.
You're in Denver, right? Denver, Colorado?
Yep, that's right.
Cool. Yeah, so there is plenty of skiing around there, right?
Yeah, we have a good few months of skiing, and so it's a lot of fun to get up there with the rest of the team on a Friday and ski. Although, I mean, it's a lot of fun to get up hiking too.
That's
We
true.
fun year round.
Awesome. Hey, are you in your office there or are you at home?
Yeah, this is my home office here, so
Cool.
I've just been. We have a pretty good remote working policy. So I mean, I usually work from home a couple of days a week, go in about I think Monday, Wednesday, Friday, and then most of the other engineers. Originally we tried to make Tuesdays and Thursdays kind of meeting free days where you could just focus, and it's been working pretty well. So a lot of times we'll just stay home on Tuesdays and Thursdays to get a lot done, and then we'll be in on Monday, Wednesday, Friday. Just in general, I mean, if there are meetings, we'll be there. Otherwise, we can work from home.
That's interesting. I work at Linux Academy now, and we have some of the similar challenges and some of the similar policies. So I see myself a lot in what you're describing there, where we do have people working from home, and then we got headquarters in Texas, Dallas Fort Worth area. And so we're struggling between, well, can we still hire remote? Should we hire only in this area or have people move here? Because it is hard to have that kind of communication when you have people in different time zones and not in the same building. I mean, when you don't have face to face, it's a different story. But at the same time, finding talent is hard if you don't open it up to remote. And it's also just sometimes it's really fun to just be home. Like right now, I'm home, right? I left a little bit earlier. I left around lunchtime and I said, hey, I've got a Skelly Code episode to do. I worked from home up until this point. Now it was 4 o'clock when we started. It's about to be 5 o'clock my time. And it's just that kind of flexibility just really helps with the morale, and it does attract that talent. And I think it's a good way to go, but it does have its own set of challenges. So that is a really interesting point.
Yeah, we've got actually an office in Dallas as well.
Oh, cool.
Uh, and we typically try to hire within that area. So, we'll hire in the Denver area or the Dallas area, depending on, where we need folks. And then we have a couple of people too, though, who have been with us for a while. They're amazing engineers, and then they decided they wanted to move somewhere else in the country. But we're fine with that. We've kind of gotten a sense for them, and we know that they're hard workers. We know that that they're amazing engineers. So we'll let them work, from wherever in the country that they happen to be, and that's no problem for us. But initially, yeah, we've been trying to make sure that, not necessarily make sure, but yeah, we have hired in the Denver area or the Dallas area or the San Francisco area, depending on what we want, and then just, yeah, providing that flexibility that eventually comes with it.
I didn't realize you were in Dallas. I don't know if you ever visit here, but if you do, let me know. We can grab some drinks.
Yeah, that'd be awesome.
Cool. Well, Travis, thanks so much for doing this episode. I really appreciate it. I learned a lot from this. And again, I do appreciate your time. If people want to chat with you or if they have any follow up questions or anything like that, how do you recommend that they contact you?
Yeah, you can. It's pretty easy. Travis at cloud-elements.com.
Are you on Twitter or anything like that or no?
Well, yeah, I just don't. I'm not a very active Twitter user, but
Gotcha.
I'm at TravisJ37.
Cool. Thank you so much. Thanks everybody for tuning in. Please leave a comment and make sure to reach out if you have any questions. Thanks everybody for tuning in.